And our next presentation is a study of methodological characteristic of domestic gas when measuring computation on gas hydrogen mixtures. Also from State Enterprise, Ivano-Frankov Standard Metrology, Ukraine, Kepeshchuk D. Yes?
Yes, it's me.
Are you ready?
Yeah, I'm ready.
Please load your presentation.
I hope you can see my presentation right now.
Yeah, very good.
Yes, okay. My name is Denis Kepeshchuk. I represent Ivano-Frankivsk Standard Metrology, and I would like to show you a presentation named Study of Metrological Characteristics of Household Gas Meters when measuring consumption of gas hydrogen and of gas hydrogen mixtures and hydrogen. So the relevance of the topic. Until now, fuel extracted from the ore depths has been used for heating and electricity both in households and industries. However, this fuel significantly contributes to the greenhouse effects on our planet, leading to global warming. So therefore, currently, hydrogen plays a significant role in solving the problem of finding the alternative.
Sorry, we can't see your presentation.
You can see my presentation?
We can't see.
No presentation, yes.
No presentation.
Sorry, okay. How I make it work? Okay.
The button with the arrow going up at the bottom of the screen.
Please load again.
Sorry. And right now, maybe?
No.
No?
Oh, yeah. Now we see it, yeah. Perfect.
Okay. For foreground.
I don't believe to this green house effect.
Right now, you can see my presentation or not?
We see
Yes.
one of the slides. It says relevance of the topic.
The topics, yes. Okay, and I continue. Therefore, currently, hydrogen plays a significant role in solving the problem of finding the alternative energy sources, as it can lead to fuel decarbonization and substantial reduction of environmental pollution. Notably, the European Union, having allocated significant funds, introduced the main direction of the greenhouse deal, the hydrogen strategy, which envisages the use of hydrogen as a fuel. So the main characteristics of hydrogen is compared to the gases is the lightest. The second one is the most fire hazardous, very low solubility in liquids, and compared to fuels, it was higher energy density by weight, but low volume. So it requires special technology for storage. And influence of hydrogen on human health.
So sorry, we are still seeing the same slide number 2.
Oh, sorry, I don't know.
Oh, yeah. Now we see the influence.
Okay.
Of hydrogen. Yes. Okay.
Okay. Yeah, I don't know why is it.
Now we see the influence of hydrogen.
Okay.
Yeah, we're good.
How hydrogen can be impact of human health? The gaseous hydrogen is highly flammable and potentially can make fires. Gas-air mixtures are explosive. Hydrogen can be absorbed into the body when inhaled. High concentration of hydrogen can lead to oxygen deficiency in the environment. and risk of inhalation. Harmful concentration of this gas in the air will be reached quickly after a leak, and when heated, hydrogen can cause strong burning or explosions as it reacts with air, halogens, and oxygens. And we have a research in our institute, and there is the 5 main phases. First one, study of the tightness of meters. Second one, determination of metrological characteristics. Third, study of the effect of hydrogen and gas-hydrogen mixtures on membrane gas meters. 4, determination of metrological characteristics of gas meters after exposure to hydrogen and gas-hydrogen mixtures. And the last one, comparison of the error results of membrane gas meters before and after experiments with hydrogen and gas-hydrogen mixtures. First phase, study of the tightness of meters. The study was conducted as follows. Tightness of membrane type meter were checked using an excess pressure of 50 kilopascal. Subsequently, in laboratory conditions, individual filling of each meter was conducted to check tightness. And the final stage of the tightness experiments involved determination and the impact of hydrogen and mixtures on the materials from the meters are made, and leading to installation of gas meters in common system, as you can see in this slide. According to the developed testing methodology, excess pressure was measured every 24 hours. The graph shows excess pressure measurements in the test line. Blue column represents excess pressure values 24 hours after inflation, and red column represents excess pressure values after daily additional injection of gaseous hydrogen. The pressure drop over 24 hours is determined by the difference in values between the red and the blue column. Phase number 2 is determination of metrological characteristics of gas meters. For this procedure, the following equipment was used as a reference rotary type meter delta and a reference drum type meter called EP, and Bluetooth transmitter and control center fan. The rotor type meter delta measured flow rates of Qmax, 0.7 Qmax, 0.5 Qmax, and the drum type meter measured 0.25 Qmax and 0.1 Qmax and Q minimum. Results. On this slide, you can see the results of determination of metrological characteristics for 5 membrane gas meters. In different colors, you can see their arithmetic mean values. Phase number 3 was the study of the effect of hydrogen and gas-hydrogen mixtures on membrane gas meters. The figure shows a laboratory workplace equipped with sensors warning of hydrogen leaks. For determining the metrological characteristics of membrane gas meters and cylinders with 100% hydrogen and cylinders with hydrogen where was 20% of gas and 80% of hydrogen, and the other cylinders with hydrogen 10% and gas 90%. A drum type meter AP was used as a reference for 0.25 Qmax and 0.1 Qmax. This table shows the result of errors during operation with 100% hydrogen and the difference errors compared to prior experiment measurements. The next slide, you can see the similar table, but in this case, we're using a mixture with hydrogen 10% and gas 90%. And the last one, where was mixture 20% and gas 80%, hydrogen 20%. Phase number 4 was determination of metrological characteristics. This phase was determination of metrological characteristics of gas meters after hydrogen and gas hydrogen mixtures. This phase was similar to the second phase, but now metrological characteristics were taken after the experiments with hydrogen and gas hydrogen mixtures. And now phase 5, the last one, was comparison of metrological characteristics before and after the experiments. The table on this slide show the arithmetic mean value at all flow rates before and after the experiments for each membrane gas meter. And conclusion, after the research was made the following conclusions. First one, membrane type meter do not fully maintain hermetically when filled with gas hydrogen mixtures, as indicated by the daily drop in excess pressure during tests. No significant changes in metrological characteristics were observed after testing with pure hydrogen and mixtures. A minor deviation within the range of up to 1% can be attributed to the design of the meters, which affects the reproducibility of measurement results. Measurement value for pure hydrogen and gas hydrogen mixtures were slightly lower than the loss obtained with air, with no notable difference between mixtures of 80% and 20%, and the other mixture where was 90% and 10% gas hydrogen ratios. And thank you for your attention. I finished my presentation.
Thank you very much. Interesting presentation. Dear colleagues, do you have any question to Denise? Zygmunt?
Yes, I have a question.
Okay.
Who is Serediuk D? Because I know Orest Serediuk from Ivano-Frankivsk.
Orest Eugenius, you mean?
Orest Serediuk from Ivano-Frankivsk. Professor
yes.
Orest Serediuk.
Yes, I know him.
Yes, and who is Serediuk D? It's any relation to the Orest or not?
Yes, Denis Serediuk is the son of Orest Eugenius. Orest Eugenius was my teacher in institute, and I'm working with his son right now.
I see. Thank you for the answer.
Thank you. Another question? No question. Thank you very much for your